Good morning, everyone. So, although it works like Friday today, it should be lecture today, but one lecture, like one tutorial, we also treat it as a lecture actually, right? So, that's the replacement. Today we will do the tutorial one day. Yeah. So, we'll start chapter 7. We have done solved one problem from chapter 7, and that is 7.1. Okay. However, we will just look at the second part of 7.1. Yeah. And that was the, it said that you had one rectangular element, 9 noded like this one, and then we have interfacing with triangular element. So just I want to discuss on this one what will be actually the shape function for this I'm talking about. Okay? So if it is 4 noded, something like this one, then let's say 1, 2, 3, and let's make it 0, whatever that be, but you just write it 0, 0 here, and A0, yeah, and this called 3 is 0, B, and 4 is 0, B over 2. Let us say these are the coordinates, and we want to construct the shape function for this. And what is the best way of doing it? We have x this side, we goes y this side, and looking at it, if you see the Pascal triangle, then we have 1 xy, x squared, xy, y squared. So we have to look at these first always, so that you know what we expect to begin with. So in this case, what happens? You have 1, 2, 3, 4. So we are looking for first 3 will be there. Yeah. Now only thing is which one of these, right? And you see that since this has 3 nodes in y direction, then you expect that it should have this one. Okay. Now next thing is how to go about it. Okay. So as we saw earlier, we do something which is easy to do first. Yeah. So you see here is just 1, and when we see y squared makes sense, then you look at n3. It's very easy to do, right? So what you have for in order to find out y the n3, you have this line which is y equal to 0. Then you have this line, this is y equal to b over 2, right? And so that really means n3 you can form very easily. n3xy is equal to y multiplied by y minus b over 2, q multiplied by alpha, right? And then you know that n3, 0, this is 0 and b, right? So 0, b has to equal to 1 is equal to alpha, and then you have b minus b over 2, and that tells you that alpha has to equal to 1, 2 over b squared, right? Okay, and that really means that we get from here n3 xy is equal to Purana sheet, you don't do it, right? It's today only, right? So don't circulate the something. Some students have already signed that sheet. You don't circulate. Right? So either you mark then, so otherwise don't give it. Okay, telling from experience. Yeah. Okay. So I have realized them also. It has happened that I gave one grade less just because he had some proxy. Okay. So be careful, guys. Okay. Okay. So a lot of you don't know me. That's why I'm telling you. The undergrads know me already. Okay, N3. Xy is 2 over b square y minus b. So this is what you get as N3. So it's very easy. Now look at this N4, right? For N4 also it's easy, right? So you have y equal to b given here. So this is 4 here. So N4 is also, you can write N4 xy is equal to, let's write beta. Then you have y multiplied y minus b, right? And you know that N4 x0 y is b over 2 is equal to 1 is equal to beta, and then you have b over 2 okay. Find that, right? B over 2 minus b. What do you get? Beta equal to minus 4 over b square. And hence N4 xy is equal to minus 4 over b square. And then you have y minus b. So it's easy. You got it? Okay, now what else? This is 1, 2, 3, 4. Now looking at one, 2, 3, 4. Looking at number 2. Whatever is easy, you do it first. Yeah. So number 2, it's very easy. It has just one line, right? This is x equal to 0. Yeah. So N2 xy is equal to what? We get equal to gamma x, right? And N2 is A0 is equal to 1 is equal to gamma A, right? That tells you that gamma, right here, gamma is equal to 1 over A, and that tells us that N2 xy is equal to x over A. Right? So we got 3 of them already. 4th one you can find out, right? 4th one is you can find out summation of n I equal to 1 to 4 is equal to 1, and hence you get n 1, right? In 1 was difficult to get. So in 1 xy is equal to 1 minus n1 minus n2 minus n3, and accordingly you get minus, you get get 2, 3, 4. So 1 minus x over a minus n3. So n3 is here. So 2 over p square y minus b over 2, right? And my plus, is it 2 or 4? Here we get 4, right?
Yes.
And here
2. 6.
2 only. So 4 over b square y minus t. So this is what we get. And of course, if you compare with this Pascal triangle, you can relate it now. So if you have constant term, you have x term, y square term, y term. Right? So you get that. And similarly, you can any other situation you do the same way. Yeah. So now when you compare with the whether it is continuous or not, now you can do it. Okay. So any question, guys?
No, sir.
Okay. Okay. Let's proceed to 7.2. So there are two triangles. Okay, exact temperature field x square. Can the two elements represent the exact solution? Okay, so we have 1, 2, 3, 4, 1, 2, 3, 4, and the values are given 2, 1, 2, 1, 0, 0. So what it says, the field is in a function of x square. Okay, the exact temperature. So the T, what is given is T xy is equal to alpha x square. This is what it is given. Yeah. Now this is asking the question whether if you discretize something like this one, whether you will get the exact solution. Yeah. What is the answer? Yes or no? Did you get it or not get it?
So if you have दोनों टर्म समझिए, सिर्फ x स्क्वायर वाले टर्म से तो
क्यों? Why do you think that way? ऐसा टर्म हो सकता है ना? This may be treated as like if it's symmetric. यहाँ let us say temperature here is something, temperature here is something, for example, है ना? So that's possible. It's possible when you have a the heat is flowing in it is flowing in the x direction only and not y direction. That can be done, right? That's not the question. Question is, this is known that temperature is a function of x square. Only thing is, if you discretize like this one, will you get the exact solution? That's the thing. Yes or no? ये इतना डिफिकल्ट है क्या? Yes or no? Yes? How?
Because we can have straight lines and boundaries in the.
Okay. For this one, how do you write T? Let's say this element number 1, element number 2. For element number 1, you will write what? T1, right? As a function of xy. Will be what? Summation of n1I, then Ti. In general, doesn't matter. Just for one, let us say temperature field is given by summation of the shape function multiplied by temperature itself. I equal to 1 to 3. Shape function n1 xy is given as what? हाँ guys, ये तो बहुत ही हल्का चीज सब you are not able to tell. Then after that you will tell that the course is difficult. Alpha 1 x plus alpha 1 beta 1 gamma 1 y. You know that if you have only 3, you will have one x y term only. Will it have x squared term? No. Then it no yet solution. No. If the temperature, your exact solution is alpha x square given, and your approximation function or test function is a function of x, y, and constant only, but there is no x square term, so automatically you are not able to capture the exact solution. Your solution is as good as the shape function. If the shape function doesn't have x square, and if you know you are given that your solution is a function of x square, you are not going to get it. Simple. इसमें तो कुछ है ही नहीं. Yeah. If you had asked, okay, instead of this, you have like this. Will it capture? It will capture now. Capture means the solution, it will admit alpha x square as a solution. That means, x square now, it is there in the shape function now. So you know that it will have x square term, and because of that, x square term, because 1, 2, 3, 4, 5, 6, so you have all these terms. 1x, y, x square, x, y square. So if actual solution is alpha x square, you will get coefficient of y square as 0, coefficient of x, y as 0, coefficient of y as 0, you will get actual solution. Main thing is like whatever order of the solution, if your shape function is of higher order, you will capture it automatically. Yeah, you will admit that as the solution, and the solution will be exact. Any question on this? Okay, 7.3. So that one of the angles. See, guys, this course is not about mathematics. Just there is an insight inside, right? There's an insight. So we also have to look at the big picture. We cannot just don't be lost in just equations. Equation comes later. Yeah. So since the beginning, we have learned that exact solution is something different thing, and then we have test function, which is a polynomial and which is prescribed. We choose what kind of, right? And this is determined by the number of nodes. Number of nodes tell you what is the order of the test function, right? So if you know that solution is of this order, accordingly you will change the order of the element. Accordingly, change the number of nodes on the element. Right? We have been doing that since the beginning. It's not new. Yeah. That was 1D. This 2D, that's the only difference. There you worried about just one direction, here you are worrying about two directions. And if you work on 3D, it will be three direction. Okay. 753, show that one of the angles in a quadrilateral is greater than 180, then determinant J may not be positive. So what it says that, see, typically you have a quadrilateral, something like this one, right? So 1, 2, 3, 4, and then we have J, right? Remember J is a matrix where we have del X over del Xi and del Y over del Xi, del X over del eta, del Y over del eta, right? And this is in XY coordinate system, and this you transfer to this you will transfer to Xi and eta system, right? And then what you have here, you have -1, this is 1, -1, -1, number 2, 1, -1, 3, 1, 1, 4, -1, 1. Yeah. So you have like this one. So now what happens? What it is asking that if this quadrilateral is not like this, you have something like one of this angle alpha. No, so let's say all alpha i's are less than 180 degrees. Then it will be J is positive. Else, if you have, let us say your quadrilateral is something like this. Yeah. So you have so let's say this is 1 here, and then you have 2 here, and then you have 3, and then you have 4. What happens? 1 to 2, this angle alpha here becomes a big angle. Right? So this one is more than 180 degrees. Right? In this case, this is more than 180 degrees. More than 180 degrees. So if that is the case, then J will be less than 0. So you can take one example, something like this one, and you can show. You can actually take a determinant, what the value is, you can find out what the value is. Okay? So you can just assume a case and you do it. Assume a case. So case will be something like you can do something like this. Let's say this minus a 0. A 0, 0b, and we make it 0b over 2. Try to do this one. For this case, find out what will be the J, the determinant, and we'll find this will be negative. So that's why you have to make sure that you don't arrive in this condition, otherwise you will face problems. Yeah. So this question only tells you that your specification should be, you have to be careful. It should be real bilateral, something like this one, not like this, otherwise it is not valid. That's a step. That will give you a problem. Okay, let's look at 7.4. One, two, three, and then you have 4, 5, 4 and 5. So you have triangle like this. Then you say construct the shape functions for the 5-node triangular element shown in this figure, which has quadratic shape function along two sides and linear shape function along the third. Okay, be sure your shape functions for all nodes are linear between node 1 and 2. Use triangular coordinate and express your answer in terms of triangular coordinates. Okay, so this is we have to see the triangular coordinate system. Yeah. So let's write. Okay, so we make the coordinate first. So this is 1. Yeah. So we have like this. Okay. So this is equal as this will be xi. Xi 1. This 1 here in front of that will be xi 1. That is xi 1 equal to 0. Yeah. And accordingly, it will come here, which will be xi 1 equal to 1. Yeah. So we have that. Then this one, this we have xi 2 is equal to xi 2 equal to 0, and you have here parallel to that. So you have xi 2 equal to 1. Fine, and then you have this is xi 3. This is equal to 0. Parallel to that, you have to draw xi 3, which is equal to 1. Yeah. Okay. Now in between we are going to assume that this is exactly in between. Yeah. So we have here, let us say we have this like this, and this is in the middle. Let's call it xi 3 equal to 1. Okay. Fine. Okay. Now we have to construct it. And how will we construct? What is easy to construct here? Which is easiest one? How will you do it? Which one is the easiest one? N3, right? N3 is the easiest one. So we write N3. N3 xi1, xi2. Basically, you know that xi3 is equal to nothing but 1 minus xi1 minus xi2. That you know. Yeah. Okay. You can also convert before this is that, and then you convert it to actual form. Actual form meaning that you transform it to, just for make it easy for you. You can also do this one. So you have like this. Then your N3 will come here, and then you have N2. Point 3 is here, point 1 is here, point 2 is here, and this is I1, this is I2. Okay, point 3 is here, and then you can see between 1 and 3 you have 5. So 1 and 3 is 5. So here it is. Yeah, so this is 5. Yeah, and then between 2 and 3 we have 4. 2 and 3 you have 4. Yeah. So this even makes life easier. Yeah. Okay. Now so this is the 5, this is 4. Now N3 is the easiest one. Easiest why? Because here also you see N3 is nothing but you multiply this and this basically, right? You get automatically. So N3 is I1 is I2 is equal to N3 is I1. You have xi3 minus half multiplied by xi3 only, right? And you will have some alpha or something, so that when you have xi1 xi2 is what value here?
0, 0.
0, 0. Here you have 1 0, you have 0 1, here you have half 0, here you have 0 half. Yeah. So N1 alpha 1 alpha 2, you have 0 0 1, sorry, N3 is equal to alpha minus half, it will be alpha 3 equal to, alpha 3 will be equal to,
2.
alpha 3 is equal to 1 minus xi1 minus xi2 is equal to 1 minus 0 for this point 3, right? Okay, so it will be 1 minus half and 1, right? So alpha which is equal to 1, so alpha will be equal to 2, and hence N3 xi1 xi2 is equal to 2 right? Got that? Okay, so what is the next one? N1. Okay, and what will be the value of N1?
Xi1 equals to 0, xi2 equals to xi2 minus half and xi1.
Xi2 equals 7 by half.
What about this 5? N5.
The
So
side
this
by
will
side
be
scale.
incorporated in phi3 minus half.
Sorry?
Phi3 minus half, whether I know that.
No, I'm asking that first we do something which is easy to do, right? And what we did, this one, these two align and you get that. And you know that in xi3 direction, it is a quadratic, basically, right? That we have seen. What it says that when you go from here to here in this direction, right? If you go from a line from here to here, then it should be linear. Otherwise, yeah, it should be like if you go in this direction, it should be quadratic. If you go in this, that's what it is telling you. But if you go from here to here, then it should be linear. So that you have to construct. So anyway, so in this case, if let us say if you are talking about N5, if you want, you are saying finding out this first, is it? Yes, and what will be the value?
So this will be by phi3 minus half, and this xi1 equals to 0.
Yeah. Okay, so there are various ways of doing the same thing. Okay, so here N3 we have found out. Now let's when you're talking about this line, then what happens? When you go from here to here, then what happens? N4 has to be 0. N2 is 0. Right? Okay. So that means it should be quadratic in xi1, right? That's what it is also telling you also. This should be quadratic in xi1. Here if you go, this should be quadratic in xi2, and that makes sense because this all these values will be 0 here. Only the xi2 the values which will be changing, right? So how will you do it? So if you say xi1, you are talking like we are talking about. If you have xi1, then if you want quadratic, then this will be you are going from this multiply by this. Then only it will make it quadratic in what? In xi1. Otherwise, it will not. Right? So that's what it will do. So you can make N2. Similarly, you can make N2. Okay, so we have N3. So we get N2 now. So N2 xi1 xi2 will be equal to. If you see here, simply you take xi1 is equal to 0. That's this line multiplied by xi1. Sorry, xi2 equal to 0. Okay, and xi2. Got it? Okay, so here also we get some beta here, and we know that N2 0 1. So we get 0 1 I is equal to 1 is equal to beta, then 1 minus half. So beta over 2, right? So that makes it what? Beta equal to 2. So we get N2 xi1 xi2 is equal to 2 xi2 is correct? It's fine? Okay. So we have that. Similarly, in N1, we will get that way. So what is N1? N1 will be, value of N1 will be xi1, xi2 is equal to, similarly it will be, you can write 2 xi1 minus half. Yeah. Okay. Now when we are going this way from here to here, and you know that this is quadratic in this direction, we will come back to N3 here. Okay. So we have chosen N xi3 was easy basically, but we will revisit this one. So right now, this is we are going through the procedure, actual procedure, how actually you will proceed in this case. We will check basically whether you add all of them, you are getting one or not. Those kind of things we have to see. So first we look at the requirement, what it says that when you go in xi direction, it should be quadratic. If you go to xi2 direction, it should be quadratic. So we have N1 which is quadratic in xi1, N2 quadratic in xi2. That we have. Now, since 4 is in this number 5 is in between these, so and 4 is also in between these, so N4 xi1 xi2 will be equal to, so this will be xi2, no, only these, no, these two lines, sorry, this and this. So you have xi2 equal to 0 and xi2 equal to 1, right? So xi2 minus 1. So let's say it's the gamma here. We're talking about this. This one is xi2 equal to 0. This is xi2 equal to 1. So this will be this. And we know that N4, xi1 is 0, xi2 is half, is equal to 1, equal to gamma, and xi2 equal to half minus 1, and that tells us what? Gamma equal to minus 4, is it? So N4 xi1 xi2 is equal to minus 4 xi2 minus 4. Similarly, you can say N5 xi1 xi2 is equal to will be same, minus 4 xi1 minus 1. Yeah, we got all of them. Now you can add them, you can find out, you have to test basically. Test if function of ni I equal to 1 to 5 equal to 1 or not. We got all of them, right? Okay, and the problem is you will not get equal to 1. Okay, why? You see, you have the quadratic here, right? You have xi2 term, xi2 square. There is no constant term, right? Here also you will get the same thing. You have the xi1 terms. N3 will have what terms? All terms. Xi1 is equal to 1 minus xi1 minus xi2. Here also 1 minus xi1 minus xi2. So all xi1 square, xi2 square, xi1, xi2, and constant. Constant, let us say we want to have 1 because of that. What about xi1 multiplied with xi2? That will remain. That will not be cancelled. So you will never get 1. That's the problem. So then what you do? Then N3, basically what you assume, basically this we cannot apply here. You will say N3 you get from here. Right? So accordingly you will get N3 equal to summation of this minus the other. Yeah. So you get N3 xi1 because N3 finding your own way, you have seen that it has problems. So hence you will not find N3 that way. You will find 1 minus summation of this. One minus N1 minus N2 N4 minus N5. Yeah. And that is equal to 1 minus, you have N3, N1, you have N1 here, so 2 xi1 minus half minus N2, 2 xi2 minus half, okay, then N4 plus 4 xi2 minus half, the N5 plus 4 xi1 times xi1 minus 1. Right? So this is what you get N3. And if you see the Pascal triangle also, if you see the Pascal triangle, and what you have in this case will be 1 xi1 xi2 xi1 square xi1 xi2 xi2 square. So you have 5 of them, so what we have used? So all of them we have constant term, xi1 term, xi2 term, xi1 square term, xi2 square term, right? Not more than that. We do not have this term. Right? So hence it is. Okay, now what about on this one? Then you go from 1 to 2. Then what happens? You have to check whether it's linear or not, right? So N1 and N2, all other values will be 0, we know. Right? So if you are moving on this one, right, on N1 and N2. So let's say where is N1, where N2, N1 and N2. So look at N1 is equal to xi1, xi2 equal to 2, xi1 minus half, right? And N2 xi1 xi2 is equal to 2 xi2 minus half. Yeah. So how is the changing? If you go from here to here, what is changing here? If you go from 1 to 2, then what is changing? Both what? xi1 and xi2 both are changing. So if you go 1 to 2, in that case, not both are changing. So you have What is the equation of this line? This is xi1 plus xi2 equal to 1, right? Okay, so you have xi1 equal to 1 minus xi2. Right? So if you express in terms of I think we'll have to plot probably. So if you express in terms of this, what happens? 2 xi1, so you will have a 1 minus xi2. So xi1, let's write 1 minus xi2, right? So 2, 1 minus xi2, right? And then you have xi1 minus, right?
So it will be half minus I.
Half minus xi1.
Half minus I2.
Uh, 2 only, no? We have 2 xi1 multiplied by 1 minus half, right? So xi1 I am writing in terms of, so see here, what we want to do. We want to determine if when you go from here to here, the values changes linearly or not. That's the thing, whether it is doing that or not, that we want to check it. How will you check it? Sorry?
So we have to check given that del xi1 is a function of xi1 only, like this.
No. Okay, so probably we don't do like this one. But how we do is basically the here we have, right? So we have this is I1, this is I2. Yeah, and this. Now what happens is our S, let us say we are going from xi1 to xi2. So we have S here. So our S square is, what is the relationship?
D xi1 square plus D xi2.
Two. Yeah, so yeah. So what you will get? So if you have, let us say small from here to here, this is ds, and this is dy or dxi. So we have like this, right? So we have ds here, and here we have dx here, we have dy here, and dy goes like this one. This is I1, this is I2, right? And our S is like this. So what do we have? D square plus D square is equal to ds square, right? Okay, and then we have a relationship between them. So ds is equal to
D xi1.
root under, but we have negative because when you go this in terms of x we are talking about. So say ds is equal to d xi1, let us say, yeah, and then we have ds equal to minus d xi1. Oh, we have minus. So minus d xi1, and then plus 1 plus d xi2 over d xi1 square. We are minus here because when you go this way, this goes the other way, right? So there will be relation like that. Okay. So we have that relation, and for this one we have xi1 plus xi2 is equal to 1, right? This is what the equation is.
It's like 3, 0.
Yeah. So xi3 will be 0. So we have 1 plus d xi2 over d xi1 is equal to 0, or d xi2 over d xi1 is equal to -1. Yeah. So ds is equal to, we have these values, minus d xi1 and root 2 basically. Minus root 2 d xi d xi1. Yeah. So this is the relationship.
Just to the negative sign, we could have seen like since we are seeing in terms of xi1, so xi1 is decreasing as we move on s. Like can we, after that we can put minus later on by understanding that xi1 is
Yeah.
decreasing.
Right. So we have that. So in terms of s, if you want to put, then how can we do it? So this, let's say our coordinate system is s this way, and here to here we have root 2 is the root 2 is the length of it. Then what happens? So n1, for example, n1, xi1, xi2, or rather we put s now, is equal to, we have 2 xi1 square
Minus xi1.
xi1 square minus
Xi1.
xi1. So this one will be simply
2 xi2 square minus xi1.
so it will be s term here, s square. This will be s square term, right? So sort of we will have the s square term. So basically this is coming quadratic only, right?
So what we need dn1 by d is something that's the. You said the change should be linear.
No, n should have a linear term. N should have a linear term. Hmm?
ds should be root 2 d xi1. Xi1 के terms में so xi1 is decreasing when we are moving on ds like this.
If you see s, then if xi1 is this way and s1 is this way. No, so when s is decreasing, you have xi1 which is increasing, right? So because of that, it's yeah, guys. So this the time is up. So we will take it up next time. Okay. So there should be it looks like it's quadratic only. Yeah. In terms of s, but if we could not, if we have to enforce this is linear, then we have to do some. I haven't worked out myself, so so yeah, that means we have to check whether that's what we are doing it. We follow the steps basically, which is natural to us. So in terms of we want something, it has to be linear in this direction. So we have to enforce this is in this direction. So but as per, although like our derivation for all the shape functions are correct, as you know from the Pascal triangle. This is how you should follow, and we got it, and that way is correct. The only thing is, if you look at whether it from here to here, whether it's linear or not, it is not. Yeah, so we will see that next time. Yeah, you also try. Okay, if you can get, else we will take it up. Okay, so time we have already 11 o'clock. So see you guys tomorrow.